have a frictionless surface. Over here, this is a horizontal surface. We have a block M1 over here. Massless string goes like this. This is a pulley. I1 is the moment of inertia of this disc about this axis, and R1 its radius. This string also goes over here, that is once again this disc which has got mass M2, radius is R2, and moment of inertia about this is I2. When this unrolls, this also brings some tension to the string. When the tension is generated in this string, some tension is also generated in this string also. As a result, this rotates, this moves in the forward direction. We are interested in writing the equations for all these three bodies. So for this, if we say that is over here the tension is T1, let's say the tension in this is T2. This will be moving only in this direction, it will not be moving on the y-axis. So equation for this is T1 is equal to M1 into A1. Let's say this goes with the acceleration A1. If we talk about this free body over this is T1 in this direction and T2 is in this direction. For this, ultimately it is alpha is in this direction. So clockwise movements minus anti-clockwise movements, we can say that is T2 into R minus T1 into R, that is net torque. Clockwise movements minus anti-clockwise movements, force into perpendicular distance, force into perpendicular distance between line of force and acceleration, that is T2 into R. This is in this direction. So T1 into R, net torque is T2 into R minus T1 into R is equal to I1 into alpha. I1 into alpha. Over here, whatsoever is the acceleration of this point, the same acceleration of this point, the same acceleration of this point, that is this point also is having an acceleration A1 only in this direction. So A1 is equal to R into alpha. So alpha, we can put it as A1 by R. We can write it like this also, because there is no slippage between a string and this pulley, there is no slippage. So A1 is equal to R alpha, because from here to here all the points have acceleration, linear acceleration as A1. So this point which is on the string and also situated on the periphery of this pulley, this is also having a acceleration A1, that is tangential acceleration is A1. So A1, A tangential is equal to R alpha, so A1 is equal to R alpha. So we get it over here. Instead of alpha, we have it written over here. Now comes, we say, let's say this is going with A2. Acceleration of this center of mass is A2. And this whole string has acceleration A1, so it means this point of contact between this and this is also going with acceleration A1. This is a point to be noted. That the whole string is going to have acceleration A1, 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 because this is not slackened. So this point is also having acceleration A1, but acceleration of A2 is more than acceleration of A1, so that's why this is unwinding. So for this, if we write the equations of linear mechanics, so downward force is M2G. M2G is the force in the downward direction. T2 is the force in the upward direction, is equal to M2 into A2, right? Net force along y-axis is equal to mass into acceleration. M2G is in this direction, T2 is in this direction, net force is M2G minus T2 is equal to mass into acceleration. Now comes applying A is equal to R alpha, that is how we can use A is equal to R alpha in this case. Over here we see, that is as we have done earlier, absolute acceleration of this is A2, absolute acceleration of this is A1. Ultimately it is revolving in this direction, it is moving in this direction, alpha is in this direction, angular velocity is in this direction. It means A2 is greater than A1, and when we say that is A is equal to R alpha, this A is the relative acceleration between this and this point. So over here, when we intend to use A is equal to R alpha formula, over here A is going to be A2 minus A1 is equal to R is R2 into alpha. This disk, this is also revolving about this axis also, this is alpha about this axis also. So let's write the equation of rotational mechanics for this. If we take torque about O, about this central axis, it is T2 into R is equal to I2 into alpha. I2 into alpha. Now what is alpha? This is a point to be noted is, when this whole thing is going with A, so this point is also going with A1 in this direction. So when this is unwinding in this direction, alpha is in this direction, it means A2 is greater than A1. And when we say, when we apply A is equal to R alpha, we know that is this A is the relative acceleration between this point and this point. We have done it earlier also. So over here, when we apply A is equal to R alpha, so it is going to be A2 minus A1. This is stands for A over here into R into alpha. So alpha is going to be A2 minus A1 by R. So over here, we put this as over here, that is T2 into R is equal to I2 into A2 minus A1 by R. So we have equation 1, we have equation 2, we have equation 3, and we have equation these 4. We can use these 4 equations to find whatsoever has been asked for in the question.